The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All righty. So yesterday we started section 10.1 dealing with the property of square roots. And today we're going to kind of expand on that, or the square root property as it's called in this book. And the idea being that if you have an equation in the form where you've got a square on one side and there's a variable inside, and over here you've got a constant, that you can take the square root of both sides of the equation and solve it that way. All right, now, what if a problem or equation is not in that form? There's a process called completing the square that gets us to that form. We're not going to cover that, but what we are going to do is talk about a formula that is made by using this completing the square process. And this formula is called the quadratic formula. It's used to solve equations that are second degree equations. And this formula looks like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients of the terms in the equation that's in the form of ax squared plus bx plus c equals 0. So when we have the equation set equal to 0 and it's written in descending powers, the first term something x squared, the second term something x, and the third term a constant, a, b, and c are the coefficients. All right, let's take a look at how this problem can work with some examples. Let's say we have the equation x squared plus 3x plus 2 equals 0. That is already in the form ax squared plus bx plus c equals 0. So in this case, a equals 1. Keep in mind there's an implied 1 coefficient in front of the x squared. B is 3, and c equals 2. Using those numbers in place of the letters and plugging it into the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now it's a matter of simplifying the arithmetic. Where's that arithmetic? Okay, so x equals negative 3 plus or minus 3 squared is 9 minus 4 times 1 is 4 times 2 is 8 all over 2 times 1 or 2. Let's see if we can shorten this up. Oops, maybe not. Okay. So x equals negative 3 plus or minus the square root of 9 minus 8 is 1 all over 2. X equals negative 3 plus or minus, well, the square root of 1 is 1 all over 2. So we've got x equals negative 3 plus 1 over 2, and x equals negative 3 minus 1 over 2. Going back to the top equation, negative 3 plus 1 would be negative 2. Negative 2 over 2 reduces down to negative 1. The bottom equation, x equals negative 3 minus 1, which would be negative 4 over 2, which reduces down to negative 2. So we get x equals negative 1. Woohoo! The voice is going, and x equals negative 2 as our two solutions to this equation. Let's check our work. Let's plug those back into that equation. So let's take the equation again. X squared plus 3x plus 2 equals 0. And our solutions were x equals -1 and x equals -2. So let's plug in -1. We get -1, the quantity squared, plus 3 times -1 plus 2 equals 0. -1, the quantity squared, would be +1, plus 3 times -1 would be what? -3 plus 2 equals 0. 3 minus 3, 0 equals 0. So it checks. Let's take x equals -2 and plug that in. -2, the quantity squared, plus 3 times -2 plus 2 equals 0. -2, the quantity squared, is 4. 4 minus 6 plus 2, 6 minus 6, 0 equals 0. So both solutions check. All right, let's continue with some more examples of this. Let's see here. We have x squared minus 18x plus 81 equals 0. This is in the form ax squared plus bx plus c equals 0. A is 1, b is -18, and c is +81. So using the quadratic formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Simplifying the arithmetic, x equals negative times negative would be +18 plus or minus the square root of, let's see, -18 times -18 is +324 minus 4 times 1 is 4 and 4 times 81 is 324.
Can I ask a question?
Yes, absolutely.
Okay, right there where you have the square root of -18, or I'm sorry, what is that, a square? And then -18 square root minus 4, 1. Is that from the formula that you mentioned earlier?
Yes.
Okay, now I get it. I wasn't sure where that 4 was coming from.
Yeah. I'm just using the formula each time. I just didn't write it because I wanted to have all the room I could use to write there. But yes, this 4.
And then you do AC, so then it would be 81, and A is 1. Oh, okay.
You good?
Yeah.
All right. Feel free to speak up anytime something's got you confused.
Okay.
All righty. Over 2 times 1 or 2. Okay. So x equals 18 plus or minus the square root of, well, 324 minus 324 is 0. So all of that over 2. Plus or minus the square root of 0, which is 0, all over 2. Well, 18 plus 0 and 18 minus 0 are still both 18. So basically, x equals 9. So we actually get 2 solutions, but they're both the same. So they're both 9. All right. Any questions about this example? Let's go on to another one then. 6x squared minus x minus 1 equals 0. Okay. So a equals 6, b equals -1, and c equals -1. Using the formula, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. By the way, you want to get this memorized, this quadratic formula. It's important. So we get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And let me do a little bit clean up here. This is 2. All right. So then we get x equals +1 plus or minus the square root of 1 plus 24, because 4 times 6 is 24 times 1 is 24, and we've got a minus and a minus, so it's a plus all over 12. X equals 1 plus or minus the square root of 25 all over 12. X equals 1 plus or minus the square root of 25 is 5 all over 12. So x equals 1 plus 5 over 12, which is 6 over 12, or 1/2. X equals 1 minus 5 over 12, which is negative 4 over 12, or negative 1/3. So x equals 1/2, and x equals negative 1/3. Any questions about that one? All righty. Let's take a look at this one. T squared equals t plus 4. Okay, now the quadratic formula says x equals a bunch of stuff, but it can be any variable. So in this case, it would be t equals whatever. But this equation is not in standard form. So I'm going to move everything to the left side of the equation. My leading term is t squared, and I want to have it with a positive coefficient. If I moved it to the right side, it would be negative t squared, and I want that a value to be positive. Just makes it easier to deal with. So I'm going to subtract t from both sides and subtract 4 from both sides. So I get t squared minus t minus 4 equals 0. It's important that you have the equation in standard form, descending powers of the variable, before you extract a, b, and c. Okay, so now a is 1, b is negative 1, and c is negative 4. So t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. T equals 1 plus or minus the square root of 1 plus 16 all over 2. Again, negative 1, the quantity squared is 1. And then you've got minus 4 times 1, which is minus 4. And minus 4 times negative 4 is a positive 16. So then t equals 1 plus or minus the square root of 17 over 2. Now, the problem is, other than the fact that my writing is messy, that's part of the problem. The problem is we can't take the square root of 17 and come out with a nice answer. It's an irrational number. We can't simplify it at all. So what we're going to do now, our two solutions would be 1 plus the square root of 17 over 2 and 1 minus the square root of 17 over 2. The instructions say solve each equation. So there are the solutions. Approximate the solutions to the nearest hundredth. Okay, now we need to be careful putting this into the calculator. So in fact, what I'm going to do is I'm going to take this and rewrite it on the next page. So t equals 1 plus the square root of 17 all over 2. T equals 1 minus the square root of 17 all over 2. Okay, so on your calculator, you want to divide all of the numerator, the 1 and plus the square root of 17, all by 2. So on my calculator, I'm going to start out by putting a parenthesis, a left-hand parentheses, then a 1 plus the square root symbol, which is going to give me this. Then I'm going to put a 17 in there. Then I'm going to close that up. And then I'm going to close up the entire thing. In fact, I want to go back and do this. Let's make that one in red. So there's two sets of parentheses. The black set groups the entire numerator. The red set groups the entire radicand, the quantity inside of the radical, okay? And I need both sets. Now, if you happen to have a calculator that when you put in the square root symbol, it doesn't give you a set of parentheses, okay? It just gives you the square root symbol. In that case, it would look like this. okay? You wouldn't have that red set of parentheses. But if it does give it a left-hand parentheses, you need to close it up and then close up the entire numerator as well, okay? Now, so I'm going to take that and put it into my calculator. Parentheses 1 plus second square root of 17, close that up, close up the whole thing divided by 2, and I get 2.5615528813. Anyway, but the direction said to round to the nearest hundredth. The hundredth spot would be right there. The 1 would round down, so my solution is going to be 2.56. That's my first answer, okay? Any questions about that? My second solution, 1 minus the square root of 17 divided by 2, and that's going to give me, let's see here, parentheses 1 minus the square root of 17, the whole thing divided by 2, negative 1.5615528813. Rounding that to the nearest hundredth, that again would round down. So we're going to get negative 1.56. So our two solutions rounded to the nearest hundredth would be 2.56 and negative 1.56. Any question about that example?
No.
All righty, let's go on to another example. This says 4w squared plus 1 equals negative 6w. So I want to put this equation that's in the variable w in standard form or descending powers of w. I'm going to put everything on the left side of the equation because my leading term is going to be the w squared term. Again, I want that to have a positive coefficient. Why is that? Because, well, back here, when we use the quadratic formula, let's go way back, we have 2a in the denominator. And if a is negative, then your whole denominator is going to be negative. And if you'll recall from arithmetic, you always want the denominator to be positive. It's easier to just have it be positive in the first place, if at all possible. So that's the reason behind that. Okay, so now I'm going to add 6w to both sides. So I'm going to get 4w squared plus 6w plus 1 equals 0. So now it's in standard form. A is 4, B is 6, and C is 1. Using the quadratic formula, W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Notice I changed it to W instead of X because our variable is W. So we've got W equals negative B plus or minus the square root of B squared minus 4AC all over 2A. Simplifying the arithmetic, W equals negative 6 plus or minus the square root of 36 minus 16 all over 8. W equals negative 6 plus or minus the square root of 20 all over 8. All right, now is where things get a little bit tricky because we're going to simplify the radical. The previous problems, we couldn't do that. And then we're going to actually reduce this whole answer down to its simplest form before we plug it into the calculator. Now, we could take it as it is and plug it into the calculator and get the decimal answers, but we want to get the reduced form of the exact answer and then go to the calculator. All right, now, let's take a look at the square root of 20. The square root of 20 could be written as the square root of 4 times 5, which could be written as 2 square roots of 5. So this could be written as W equals -6 plus or minus 2 square roots of 5 all over 8. Do you see that -6 and 2 square roots of 5 and 8 all are even? They all have a factor of a 2. So we could reduce that down. And we could write it like this. First, what I'm going to do is I'm going to split it in half, or split it apart, I should say, not in half, but the separate terms, okay? Then I'm going to reduce that one and reduce that one, okay? 6 over 8 is 3/4, 2 over 8 is 1/4, and even though there's an implied 1 now in front of the square root of 5, I don't technically need to put it there. It's implied, okay. So now I've got this. I've got the same denominator, so I could, in fact, write it like that. So what I've done is I've reduced that down by taking a 2 out of each term in the top and a 2 out of the bottom. Are you okay with that?
Yes.
Okay, so there's our two exact answers. I'm going to copy those on the next page. W equals -3 plus or minus the square root of 5 all over 4. So my two solutions, W equals -3 plus the square root of 5 over 4, and W equals -3 minus the square root of 5 over 4. And now I'm going to go to the calculator. So again, I'm going to put in parentheses -3 plus the square root of 5 divided by 4, and I'm going to have that extra set there. And then here it's going to be -3 minus the square root of 5 divided by 4. Again, that extra set there. So let's see what happens here. Parentheses -3 plus the square root of 5, close it up, close the whole thing, divided by 4. And I get -0.1909, etc., rounding to the nearest hundredth. That 9, the 0 rounds down, so W equals -0.19. And then our second situation, we get W equals -1.309, 0, etc. Here's the 100th place, the 9 rounds up, so W equals -1.31. Okay, so here are the exact answers in reduced form, and then their decimal equivalents rounded to the nearest hundredth. Any questions about that? Okay. Now, there's some things that we can do with equations to make them easier to deal with, plugging them into the quadratic formula. All right, so first of all, let's take a look at this situation. -5x squared plus 9x minus 2 equals 0. Remember I talked about how it would be nice to have a, the coefficient of the leading term, positive. Well, in this case, a is negative. Now I could just take everything on the left and move it over to the right side, and that would change it to a positive 5x squared. But the other thing I could do, which would work equally as well, would be to just multiply both sides by -1, which gives me 5x squared minus 9x plus 2 equals 0. Okay, so then A is 5, B is -9, and C is 2, and we could proceed from there. Okay, that's all I'm going to do with that one. The directions just say write it in an easier form to solve, but don't solve it. Okay, another case, let's say we've got 1.6t squared plus 2.4t minus 0.9 equals 0. This is in standard form. A is 1.6, B is 2.4, and C is -0.9. You could use those values and plug it into the quadratic formula, but it's going to get kind of messy. So it would be better to get rid of the decimals. If we move each decimal point one place, we'll get rid of the decimals. To do that, we'll multiply both sides by 10. So I get 16t squared plus 24t minus 9 equals 0. So now A is 16, B is 24, and C is negative 9. And then you could plug those into the quadratic formula to get the solution. Okay, here's another example. Let's say we've got this 1/8 x squared plus 1/2 x minus 3/4 equals 0. This is in standard form. A is 1/8, B is 1/2, and C is negative 3/4. If you use those and plug them in, it really gets messy. It gets very tricky dealing with all those fractions. It's doable. You can get the right answer, but typically it doesn't happen. It's better to get rid of the fractions. So to clear the fractions, this takes us back to beginning algebra. If you happen to take it from YBC, it goes way back to chapter 2 in solving fractional equations. You multiply both sides of the equation by the least common denominator. So the question is, what is the LCD, or least common denominator, of 8, 2, and 4? And the answer is 8. Good job. So we're going to multiply both sides by 8. So I've got 8 times 1/8 x squared plus 8 times 1/2 x minus 8 times 3/4 equals 8 times 0. Going across and simplifying each product, the 8's reduced down to 1/1, and we end up with 1x squared plus the 8/2 is 4/1, so plus 4x, and the 8/4 is 2/1 minus 6 equals 0. So now A is 1, B is 4, and C is negative 6. Much easier to deal with than the fractions. And finally, here's another example, 33y squared plus 99y minus 66 equals 0. If we look at the three coefficients, 33, 99, and minus 66, or negative 66, can you see that they all are divisible by 33? So I could divide both sides of the equation by 33. Again, that would make the numbers nicer. A is 1, B is 3, C is negative 2. Now, if you left it with the original numbers, you could still get the answer, but you'd get this huge quantity that you'd have to reduce down and everything. Better to simplify it in up front. So we've looked at how to get rid of a negative leading coefficient, how to get rid of decimals, how to get rid of fractions, and how to reduce it down if there's a common factor in all of those. Let's see here. Let's take a look at some more examples. Okay. X times x minus 27 equals 280. It says, solve each equation, approximate the solutions to the nearest hundredth when appropriate. Okay, so if it comes out irrational with a square root of some number, that's when we would go to the decimal approximation. So I got to get this thing in standard form. So first of all, on the left, I'm going to distribute x squared minus 27x equals 280. I'm going to subtract 280 from both sides. So x squared minus 27x minus 280 equals 0. Okay, I don't have any decimals or fractions to worry about. My leading coefficient's positive. I don't think I can divide out something to make it nicer. So I've got A is 1, B is negative 27, and C is negative 280. So using x equals negative b plus or minus the square root of b squared minus 4ac the whole thing all over 2a. If you write the formula before you do each problem and keep trying to write it from memory, you'll get it memorized. So I've got x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The place that people mess up the most is inside that radical with those negative and subtraction signs. So be really careful with that. So then we've got x is 27 plus or minus the square root of, let's see, negative 27 times negative 27 is going to be positive 729. And then minus 4 times 1 would be negative 4 times negative 280 is going to be a plus. Let's see, 4 times 280 is 1120 all over 2 times 1 or 2. Okay, so x equals 27 plus or minus the square root of, let's see here, 1120 plus 729 is 1849. That's not the year I was born. It's the year I graduated from preschool, all divided by 2. Okay, now 1849, what a huge number. I think the first thing I would do is see if by chance that is a perfect square. So I'm going to, on my calculator, I'm going to take the square root of 1849. It's exactly 43. So x equals 27 plus or minus 43 all over 2. Who would have thought? All right. So then x equals 27 plus 43 over 2, which is 70 over 2 or 35. X equals 27 minus 43 over 2. Let's see, 27 minus 43 is what? Negative 6. Come on, eraser, don't fail me now. Negative 16 over 2, which is negative 8. So x equals 35 and x equals negative 8. Something you want to watch for, I don't know if it'll show up on this assignment, but on some of the assignments where there's 2 answers, it tells you to write the smaller one first. So make sure you do that, because you can have the 2 right answers and switch them and get them both wrong when they're really right. You just didn't follow directions carefully. Another situation that comes up, there's a case where it'll say write the smaller answer first, and the 2 answers will be the same. So how do you determine which one's smaller, which one's larger? If they're the same answer, you can put either one in first and last, and it'll be okay. All right, let's see here. How about this one? How are we doing for time? We got time. 900x squared minus 8100x equals 1800. Okay, so first thing I'm going to do is get it in standard form. I'm going to subtract 1800 from both sides of the equation. 900x squared minus 8100x minus 1800 equals 0. Can you see that each of those terms I could divide by 100? So let's do that. And I'd get 9x squared minus 81x minus 18 equals 0. Oh, there's something else we could take out of each one. What is it? Can you see it?
They're all divisible by 9.
Right. And I could have just divided everything by 900 to start with. But in fact, let's do that. That'll be easy to fix. We'll go back here and we'll just make this a 900. So if you see something and you take it out, look and see if there's anything else you can take out. X squared minus 9x minus 2 equals 0. I think that's right. Yeah, okay. So now A is 1, B is -9, and C is -2. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. You know, there's a lovely little song that you can use to memorize this. X equals negative B plus or minus the square root plus or minus the square root of B squared minus 4AC, B squared minus 4AC all over 2A, all over 2A. I know what you're thinking. Keep your day job, right? Okay.
I wouldn't want to sing myself either.
Okay. So now we've got X equals 9 plus or minus the square root of -9 times -9 is positive 81. -4 times 1 times -2 would be +8 all over 2 times 1 or 2. X equals 9 plus or minus the square root of 89 over 2. Okay. 89 is a prime number. It doesn't have any perfect square factors. So my two exact answers are going to be X equals 9 plus the square root of 89 over 2, and X equals 9 minus the square root of 89 over 2. And then going to the calculator. So for the first one, parentheses 9 plus the square root of 89, close up the 89, close up the entire numerator, divided by 2, and I get 9.216. So the 6 would round up and we'd get 9.22. Okay. Then the second one, parentheses 9 minus the square root of 89, closing up the 89, closing up the whole thing with a final set, divided by 2, negative 0.2169. The 6 is going to round up, so negative 0.22. So here are the exact answers and the decimal equivalents. All right, so tonight's assignment is going to focus on solving equations using the quadratic formula. Tomorrow we'll come back and we'll do some application problems using the quadratic formula. Do you have any questions before we go?
No, I'm good.
All righty, well, I will turn off the recording and I'll be back this afternoon at 1:15 should anyone need me. Take care. Bye.
Bye.